This question comes from Alex, who asks, if you could travel at 99% the speed of light, not in a spaceship, just you, somehow moving through space at that speed, what would you actually experience? And what happens when you come back? Great question, Alex. The answer involves time, death, and everyone you've ever loved being gone before you return. Let's go. The number light travels at 299,792,458 meters per second. That is roughly 1.08 billion kilometers per hour. At 99% of that speed, you are moving at approximately 1,067,000,000 kilometers per hour. For comparison, the fastest human-made object ever launched, the Parker Solar Probe, reaches about 690,000 kilometers per hour at its peak. You would be moving roughly 1,500 times faster than that. At this speed, you could travel from Earth to the Moon in about 1.3 seconds. You could reach Mars at its closest approach in about 3 minutes. You could cross the entire solar system in a few hours. The scale of what we're discussing here is almost impossible to hold in your head, all at once. So let's just start moving and see what happens. The first few seconds. The moment you reach 99% the speed of light, the universe does something deeply strange. It changes shape. Directly ahead of you, the stars begin to shift. They cluster toward the center of your field of vision, crowding inward as if being pulled toward a single point. The sky ahead becomes denser with light. This is called relativistic aberration, the way your extreme velocity distorts the apparent positions of everything around you. Simultaneously, the stars ahead begin turning blue. The light waves from objects in front of you are being compressed by your motion, shifting their frequency toward the blue end of the spectrum. This is the Doppler effect, but at a scale that makes sound-based examples look trivial. Stars that were yellow become blue-white. Stars that were invisible in infrared become visible. The sky ahead is electric and strange. Behind you, the opposite happens. Everything turns red. Stars fade toward infrared and beyond. The sky behind you grows dim, then dark. You are outrunning most of the light coming from that direction. The universe has been neatly divided into a blazing blue hemisphere ahead and a fading red darkness behind. Time. Now here is where physics stops being comfortable. At 99% the speed of light, time dilation becomes severe. Einstein's special theory of relativity tells us that time does not pass at the same rate for all observers. The faster you move, the slower your personal clock runs relative to someone who is stationary. The formula gives us a Lorentz factor of approximately 7 at 99% light speed. This means that for every 7 years that pass on Earth, only 1 year passes for you. This is not a metaphor. This is not a feeling. Your heart beats slower relative to Earth. Your cells divide slower. Your thoughts happen slower. You age slower. 1 year of your experienced life equals 7 years of Earth time. You decide to travel to Proxima Centauri, the nearest star beyond our Sun, about 4.24 light-years away. At 99% light speed, the journey takes you approximately 4.3 years of Earth time to complete. But thanks to time dilation, you personally experience only about 7 months of travel. You feel 7 months older. You eat roughly 7 months worth of food. You sleep, think, and exist for 7 months. You arrive at Proxima Centauri. You turn around. You come home. The return. You land back on Earth. The journey felt like 14 months total. 7 months each way. You step out. You're just over a year older than when you left. But Earth has aged 8.6 years. Everyone you knew has aged nearly a decade. Children you knew are now teenagers. People who were middle-aged are now approaching old age. The news is different. The technology has changed. The cultural references you left behind are now nostalgic. The coffee shop near your home might have closed. This is not science fiction. This is the verified, experimentally confirmed prediction of special relativity. We have measured time dilation using atomic clocks on aircraft and satellites. GPS satellites must account for time dilation in their calculations, or they would give wrong locations within minutes. The physics is real. Now imagine not going to Proxima Centauri. Imagine going further. Going further, you decide to visit the center of the Milky Way, about 26,000 light-years away. At 99% light speed, Earth time for the journey is about 26,300 years. But your personal experience time, thanks to time dilation, is roughly 3,700 years. Still an enormous personal journey. But you would arrive having aged 3,700 years while Earth aged 26,300 years. Human civilization as we know it is about 6,000 years old. A 26,000-year round trip means that when you returned, if you could somehow survive the journey biologically, every language you spoke would be extinct. Every nation that existed when you left would be gone. Every building, every institution, every name you recognized would have vanished thousands of years ago. You would return to a planet that had completely forgotten you existed. If you pushed further, say to the Andromeda Galaxy, 2.5 million light-years away, the numbers become civilizational. Earth would age millions of years in your absence. Humans as a species might no longer exist. The continents would have shifted. Evolution would have run its course in entirely new directions. The sun itself would be noticeably older. You would return to a planet that might not recognize you as a species. The energy problem. Here is the part that prevents us from actually doing any of this. Accelerating mass to near light speed requires energy, not a lot of energy, an incomprehensible amount of energy. The kinetic energy of a single 70-kilogram human traveling at 99% light speed is approximately 2.7 times 10 to the power of 19 joules. That is roughly equivalent to the total global energy consumption of humanity for about 40 years, just to move one person to that speed. And that assumes perfect efficiency. Real engines are not perfectly efficient. The actual energy requirement would be orders of magnitude higher. There's also the problem of interstellar dust. At 99% light speed, even a single hydrogen atom hits you with the energy of a high-speed proton in a particle accelerator. Interstellar space is not empty. It is full of particles that at this velocity become lethal radiation. The engineering challenges are not merely difficult. They are, with current physics, impossible. The final answer. So what actually happens if you travel at 99% the speed of light? The sky transforms. Stars cluster ahead in blue, fade behind in red. Time slows for you. 1 year of your life equals 7 years on Earth. A trip to the nearest star? 7 months for you, 4.3 years for Earth. A trip across the galaxy? 3,700 years for you, 26,000 years for Earth. Return home. Everyone you knew is gone. Civilization has moved on. The energy cost, equivalent to 40 years of total human energy output per person. The dust problem. Interstellar particles become lethal radiation at this speed. Time is not a river flowing at the same rate for everyone. It is more like a river that moves faster in some places than others. And the faster you move through space, the slower you move through time. The universe is consistent, precise, and completely indifferent to how uncomfortable this makes us feel. You could travel to the stars and come back young, you just can't come back home.